Section 10.9 is on what we call cross-section. Now the cross-section, the definition is right up here at the top. It's cross-sections are two-dimensional figures. Now let me stop there for a second before I give you the top part. We've been talking in this whole chapter about three-dimensional figures, not two. We've been working with all solids where they have length, width, and height. This is the one section where we're just talking now about the two-dimensional, just things that you would see on your paper, like a square or a rectangle or a circle or a triangle or whatever, where it's just got two dimensions, length and width. So these are two-dimensional objects formed by cutting a three-dimensional shape with a plane. So it's like you're taking your tabletop or some kind of a plane and slicing your solid that you had. You're slicing it into pieces. And after you slice the pieces, you hold it up and you look at it and you see what shape it made. That's what a cross-section is, to find out what shape it made when you cut it. So I was using the illustration of this cantaloupe. We're going to say the cantaloupe's a sphere. When you slice the cantaloupe right in half, what do you get to see? You get to see a circle. So the circle is what the shape would be. So very easy section as far as just looking for the shape of the cross-section. Now, the cross-section is a two-dimensional view of the interior of the three-dimensional figure. So you're looking at the inside of the shape. You're slicing it open so that you can see the inside. So that's kind of what we're doing on these. Okay, so the blue cylinder over there. You see the blue cylinder? Blue cylinder has what shape, if you were to slice it open and just look at it, look at your cut, what would you see? You would see a circle. So your cross section would be a circle. Inside, you would see a circle. So again, we're just going to be drawing some shapes here. You're going to be just writing some names to some shapes. Pretty quick and easy notes. If you've got a square prism, that's what this is right here. It's a square on the top, it's a square on the bottom, and it's a prism. What would my cross-section be if I used a plane and sliced it? That would be a square, yes. The cross-section would be a square. That's what you would see after you slice it and you look at it, you'd see a square shape. The last one there is a rectangular prism. That means the base is a rectangle and the four triangles come up to a point. It's a rectangular pyramid. So if you sliced it right here across, that means it's parallel to the base. What shape would you see there? Yeah, you would see a rectangle. That'd be a rectangle shape. Okay, moving on. Cross sections of a cube. Let's just write down what each cross section would be. So if they cut the cube like this first section up here, like this first one, what would be the cross section for the cube? Yeah, you would see a square. So if you cut it, sliced it like that, you would see a square. What if you sliced it from one corner to the other corner in a diagonal fashion? Yeah, you would see a rectangle because the diagonal is a little longer than the sides. So it would be a rectangle. Now the third cut is kind of an interesting cut. It's kind of at a weird angle. They sliced it so that you would actually see six sides.
Hexagon.
It's a hexagon, yeah. You would actually see six sides. If you look at the board up here, in green, you can kind of see that where the six sides would be. That's a six-sided figure. Now, these last two are the same. Now, if you cut off a little pyramid, then what would the bottom look like? It would be a triangle, yes. To those two, it would be a triangle.
Oh, so we're looking at the flat.
Just looking at the flat part. We're looking for the two-dimensional shape. Okay, cross-sections of spheres, prisms, and pyramids. Okay, name each one. Now, if a plane just sits on top of the sphere, what would my cross-section be? Just a dot, right? Just a point. So this right here would just be a point. That's just sitting right on top. It's just a point. But what if it looks like the second figure? What if we sliced off a part of the sphere? It'd be a circle. I want you to notice in this diagram right here that no matter how you slice the sphere, it's always going to be a circle. Always. You could slice a little piece off your bottom. You could slice a big piece off here. You can go across the middle. You can go down. It doesn't matter. You'll always get a circle. But let me do one thing really quick. A circle cross section that has the same radius as the sphere is called the great circle. So if you cut the sphere in the middle where the circle that you see is the same radius as the sphere itself, then we call that the great circle. What do we call the great circle for our Earth? The equator. So if you were to cut it through the equator, you would have what you would call the great circle. Okay, you had a question? Okay, well, that's coming up. Okay, so a triangular prism, if you sliced it, this red shape would be a triangle there. A rectangular prism, sliced it, the red shape would be a rectangle. Yeah, probably could. It could be, there could be different things. Now that's just if we cut it at parallel to the base. If we made it different angles, it could be a different shape. Now if you took a pyramid, let's say this is a square pyramid, you sliced it right down the center, you would see the green lines in there would make a triangle. Yes. Now there, again, there's different ways you could slice it, but in that case you would see a triangle. It would basically be the same as the face there in the front. Okay, the last one, you might recognize a few of these from last year in Algebra 2. In Algebra 2, there is a section on conic sections. Conic sections are made from cones. And you might have seen some of those last year. So look at this first picture. If we were to slice off a piece of cone like you see there, okay, that would be a U shape right there, and it would be an N shape at the bottom, right? So that's what we call them, and they're right up here in the top one. Let's take a look. So the first one, if you just slice off the top of the cone, you would get a circle. I know you can't read that, but it says circle, so you can write that in there, circle. Now, if you slice it at an angle, like you see right here, that's going to be what we look like an oval, but we call it an ellipse. Okay, it's called an ellipse, and in Algebra 2, you learn how to find the equations of ellipses. Not what we're doing in here right now. We're just looking at the different cross sections that you would see. The cross section here would be an ellipse or an oval shape. Now, let's say you sliced it parallel to your slant height. So it's parallel to the slant height. That would be a parabola. When it's parallel to the slant height, it looks like a U-shaped curve. That's what you do with your x squared graph, your quadratic graph. That's going to be a parabola. If you were to slice it like this first picture where it's perpendicular to the base, we call that a hyperbola. It's called a hyperbola. It means it was parallel to the base. What would happen if you took the cone and sliced it straight down the middle like we did in that other pyramid? You would get a triangle. So yes, you could have a triangle right here. I know, but I couldn't fit all the cool pictures that I found on there. Okay, so let's review. Let's see if we can get these. This bottom one, you can look at the color coding. The red would be what? A circle. Okay, the yellow would be our ellipse or oval. The green, when you slice it at the same parallel to the slant height, that's the parabola. And when you slice it perpendicular to the base, that's the hyperbola. So that's where those go. Now look at the next figure. It's kind of a different figure, but the same concept. The purple up here on the board, the purple is to the same as the slant height. So that would be the parabola this time up top. The green is at a diagonal on the cone. So the green is the oval, or what we would call the ellipse. The blue one down here at the bottom, that's our circle. That's right there. And then the orange one over here where they went parallel to the, or perpendicular to the base, that was the hyperbola. Okay, what do you think this top one is up on this last picture? That's the parabola. Yep, that would be your parabola up top. What about down here in the middle? That's your circle. Down here at the bottom, that's your ellipse. I'm not sure where I put this. There it is. And then your last one, picture where you cut them just like the very first one, both of those would be your hyperbola. So those are just the way that they make a conic section. A conic section is from a cone. Where you slice a cone into different sections, you're going to see different shapes. So those are the shapes. Now on your practice problems, which are on the next page on there, you look at them, they're pretty easy. You're just going to name the three cross sections, and then they're going to describe you five, and you just have to tell me what shape they are. So those are your practice problems. You'll do those today or tonight or whatever.